And welcome back. Our next speaker I've known for at least 10 years. We've been on panels together. He's been an advocate of a vegetarian diet all this time and has tried to convince people that, you know, this is the way to go. But his vocation at the present time is as an intensive care doctor taking care of people in Washington, D.C. But he also continues to try and press the cause. And I'll let him tell you about where his passion came from and what he expects to do. I want to introduce Dr. Milton Mills.
Thank you. Thanks, John. Well, good morning, everybody. This is my first time being at one of these events, and when John called or emailed me and asked me to participate, I was extremely honored. Then I got here and saw that he put me directly after Michael Greger, and I thought he liked me. So, you know, Michael's a hard act to follow, so I've decided that to try and, you know, pump up the presentation, there's going to be fireworks toward the end and a magician for the kids, so you guys may have to move back. Actually, I also want to just kind of apologize for not wearing a tie, because, you know, everybody looked very nice and formal, but exactly 1 month ago, on the 13th of January, I had a triple disc fusion in my neck. And importantly, this was not from degenerative disease. About 12 years ago, I was involved in a very violent motor vehicle accident. I was driving a car on my way to a conference, and the car was struck by a airport shuttle van, totaled, and ended up with a ruptured disc in my neck. And the problems progressed to the point where I was having difficulty walking, couldn't stand for long times. I had weakness and muscle atrophy on the right side of my chest. So I'm doing much better now. The leg stiffness and discomfort is gone. And so I think that hopefully by the next time you see me, now that I can move normally, there will be less of me to see. But I just want to share one thing that was really interesting about the whole experience. You know, obviously, because I'm getting operated on my neck, and there's just so much there that can go wrong, I actually saw 3 different neurosurgeons before I picked one. And the one thing that struck me about each and every one of them was that when they put my MRI onto the computer and saw how far those discs were pressed into my spinal cord, their jaws dropped open, and then they asked me, "How bad is your pain?" And one doctor actually asked me that as he's reaching for his prescription pad. And I said, "I don't really have pain. The problems I have are the mechanical ones with the, you know, difficulty walking and so on and so forth." And I attribute the fact that I didn't have a lot of pain to being plant-based and having a low level of inflammation in my body. So just want to share that with you guys. I think I shared it with my docs. I hope it made an impression upon them. So, all right, well, what am I going to talk to you about? All right, you guys have heard people talk to you about the fact that being plant-based is healthier for you, it's healthier for the planet, and of course, it's the animals appreciate it because they don't get mistreated and killed. But I know that there is at least one person out here in this audience who is panicking because all your life you've been told that you are an omnivore, that you are supposed to eat both meat and plant foods, and suddenly everybody here is telling you that you shouldn't eat only plants, and you're like, oh my God, what am I going to do? It's kind of like if someone came in and said, you know, oxygen kind of helps fires to burn, so maybe we should stop breathing. I mean, we don't think, but I like to breathe, and I kind of need to breathe. And so you may be thinking, wait a minute, okay, you know, cutting out meat will reduce my risk for cancer and heart disease, but won't I be missing something? Won't I, in some way, become unhealthy? Because I'm sure, like me, you've all heard these apocryphal stories from people. Oh, I went vegetarian, and I went vegan, and I was so weak, and I was so tired, I couldn't make it. My belief is that if you go vegan or vegetarian and you don't enjoy it, it's like sex. If you don't enjoy it, you're not doing it right. So what I'm here to explain to you guys is the why of all this. I'm here to let you know that, number one, you, like Humphrey Bogart in Casablanca, you've been misinformed. You are not an omnivore. You are an herbivore. And hopefully by the end of my lecture, I will have convinced you of that. Then we can turn on that disco ball and have a little party. By the way, how many of you knew there was a disco ball? All right. So with that, let's get started. The title of this lecture is, Are Humans Designed to Eat Meat? And just to give you a little heads up, the answer is no. This is a quote from the book of Genesis. God told our foreparents, you shall eat the plants of the field. It was good advice then, great advice now. All right, as we have heard time and time again, most recently from Dr. Greger, experts estimate that up to 80% of the major disease and premature death in this country could be prevented by making major changes in our diet and lifestyle. Well, given that fact, I want to submit to you that if you want to get the person who is a real danger to Americans, in addition to not voting for that guy, we also need to go after this one. All right, so how are we going to tackle this question of what we should be eating? Well, what we're going to do is we're going to look at mammalian carnivores, animals designed to eat meat. We're going to look at mammalian herbivores, those that are designed to eat plant foods. And then we're going to look at humans and see who we most closely resemble. And the reason this word metrics is up here is because one overriding theme I want you guys to keep in your mind is the idea of energy costs. The energy costs of procuring the food that you eat. Because clearly, in nature, if you expend more energy either looking for or procuring food that you can extract from that food, you don't survive. You starve to death. You die. And many of these ridiculous theories that people have put out about how humans somehow survived on hunting don't add up. The metrics don't work. It would require so much energy trying to hunt and find these animals that we would always be in an energy deficit and we wouldn't survive. That is in the absence of course, modern guns and this sort of thing. So, clearly, animals that are designed to eat this stuff have a very different issue to confront than animals that are designed to eat the other guys. The stuff on your left is anchored in the ground. It doesn't kick you. It doesn't spit at you. It doesn't try to stab you. And so it's pretty easy to eat it when you find it. Problem is it tends to be spread out over very, very vast distances. Now the other guys typically don't want to be eaten. They're not like Charlie the Tuna saying, oh, eat me, eat me. They will run away, and if you catch them, they will kick you, they will try to stab you with their horns, they will do everything they can to get away from you. So animals that are designed to eat plants are designed to forage. That means they are designed to cover very large distances over broad areas at very low energy costs. Why? Because again, if they expend more energy looking for the plant foods they eat than they can extract from those plant foods, they won't survive. On the other hand, animals that are designed to eat other animals are designed to run very fast, unfortunately, for them for short periods of time, to be able to tackle these animals, take them down, kill them without being injured themselves. And so we see that carnivores, the meat eaters, are optimized for predation. Herbivores, as I said before, are optimized for foraging. I've already covered this. Carnivores, because of this, carnivores do not go out and look for the biggest, strongest, most robust antelope on the savannah. Why? Because that antelope is likely to outrun them. If they catch up with it, it is likely to injure them so that they won't be able to hunt anymore. So instead, they look for the weak, the diseased, the defective, or the stupid ones, because those are the ones that are easier to catch. But the herbivores, they don't want the defective, the dried out, the broken down plants, because those plants are not nutritious. Instead, they look for lush, verdant, healthy, and one you can think of it as beautiful food. Well, this is important because when you have a creature that preys on other creatures using this herbivore mentality, that is looking for the biggest, the best, the healthiest, what ends up happening is that it depletes the gene pool of that prey species and drives them toward extinction. And yesterday, Dr. Ripple talked about these issues when he talked about human carnivory. When we go out and hunt, we pull out the biggest, we pull out the strongest, we pull the best genes out of the gene pool of these species that we prey on, and that is why we are destroying this earth and driving these animals towards extinction. So this brings up the concept of what I call the beauty paradigm and species destructions. Species survival in nature, as I said before, is fundamentally a question of energy in versus energy out. If you expend more energy obtaining food than you can get from the food, you don't hang around, you don't make copies of yourself. So for this reason, all true predator species look for what can be thought of as ugly food. They want food that requires a minimum expenditure of energy to procure. That is why they look for the lame ones, the old ones, the diseased ones, or the very young. They do not waste time chasing the fittest, healthiest members of their prey species because, again, they are more likely to either be outdistanced by those animals or even if they catch up to those animals, to be injured by them. And they also look for food that's already dead because they have the physiology that allows them to eat rotting tissue without any injury. And while we may find it disgusting to think of eating a rotting carcass, the fact is the energy content of a rotting carcass is exactly the same as that of a fresh one. The energy content of a massive tumor is exactly the same as healthy tissue. So they don't mind eating an animal with cancer because that animal is going to provide for them. Number one, it's going to be easier for them to catch. Number two, it provides the same amount of energy as an animal without a disease. And again, behaving in this manner means that they strengthen the gene pool of the species that they prey on by weeding out those that are less fit. As I said before, the herbivores seek the beautiful plants because those are the ones that are most nutritious. And when we humans, because of our herbivore mindset, that's the concept I want you guys to grasp, is that we have the mindset of an herbivore. We want food that is beautiful, that is robust, because we equate those qualities with health. But when we use that mindset to hunt other animals, we end up destroying the earth. By the way, eating the healthiest plants is actually a good thing because what happens is every time you poop, you spread the seeds of those plants and you help them multiply and spread. So let's look at a typical carnivore. This is a wolf. First thing I want you to notice is that they have a very streamlined shape so that they can run very fast. They have an armored front, meaning that when you look at their chest and shoulders, their shoulders are heavily padded. Their chest is enclosed in their rib cage so that as they're running up behind an animal, if that animal tries to kick them, it's likely to kick them on the padded shoulders or maybe kick them in the chest where they're protected by their breastbone and their ribs. The most vulnerable parts of this animal, the unprotected abdomen and the gonads, are all the way at the back where they're the most protected from injury. They have a very thick, muscular, sturdy neck, forward deployed weapons. If you've ever looked into the face of a snarling dog, you know exactly what I mean. Their top speed is roughly about, except for the cheetah, which is an extreme example, about 35 miles an hour, and that enables them to ambush and capture the sick, the injured, and the unwary. They have what's called a digitigrade stance. And by the way, there's going to be a mini exercise moment later on in this lecture. What digitigrade means is that they are up on their toes. their heels are off the ground. Now, when you or I get ready to run, what do we have to do? We have to crouch down, get up on our toes, on your mark, get set, and then we run. These animals don't have to do that because they're already permanently on their toes. Their joints are already permanently flexed so that they are always ready to run. And the digitigrade stance also lengthens their legs, which helps them run faster. Their nails are sharp claws, which not only helps them to grapple with prey, but act like sprinter spikes and allows them to really grab the ground. They have the permanently flexed joints, as I mentioned before, which you guys will see in a minute. And that means, though, that they must use energy to resist gravity. So I want everybody who can stand without difficulty, stand up, please. Okay, now as you guys are standing here, straight, standing up, anybody having any problems? All right, now what I want you guys to do is crouch down like this and stay that way. All right, who's starting to feel the burn? Now it's your muscles that are resisting gravity, and you can feel the difference. It takes a lot more energy to stay in this stance. All right, go ahead and sit down. That is why when carnivores are not actively chasing prey, they go lay down because it takes too much energy for them to stand. They have these skinny, lightened limbs that, again, reduces the energy cost of running. Their feet are reduced in size. Their toes are reduced in number. And again, every time they lift their foot to move and run, that reduces the energy cost of running. Their senses are tuned to finding other animals. So their hearing is super acute, so they can hear animals moving. Their ears will swirl around like little radar dishes so they can help locate prey. Their eyesight is optimized for night vision. And it's also designed to follow movement. Now, I've heard people say, well, we have binocular vision like the carnivores, so that means that we should be carnivores. Well, that's kind of like saying a hummingbird has wings like an eagle and therefore it should be, killing prey. I mean, that's kind of silly. Binocular vision gives you depth perception. And clearly, carnivores, if they're going to be chasing something down, need to have good depth perception so they can come up on the prey and know where it is. However, we use our depth perception for a different purpose, and we'll talk about that when we come to humans. But in a human being, in the back of your fovea, there is a pit called back of your retina, forgive me, is a pit called the fovea. And in that pit it's lined with cones. Cones are the cells that give you very precise, discrete vision and color vision. Carnivores don't have a fovea. What they have along the back of their retina is called a linear streak. That is where the highest concentration of photoreceptors are located, and it allows them to detect and follow movement very easily. That is why if you drag something in front of a carnivore, like a cat or dog, they are duty-bound to chase it because it's moving across that linear streak and their brain tells them, run after it, chase it. Their night vision is more than 6 times better than ours. They have permanent night vision goggles, but it has very low resolution. That is why they hunt primarily at night. Now, you would know this from watching nature shows like I do because these people spend months and months and months sort of to get a few feet of film showing hunting during the daytime, but the vast majority of hunting occurs at night. Why? Because prey animals are asleep. And if you can sneak up on a sleeping animal, it's going to require less energy to get that animal. Their sense of smell can be more than 100,000 times more powerful than ours. It's sensitive enough to detect and track prey at great distances, but this is what's really critical. It can also identify prey with cancers, infections, and metabolic disorders. There was a team that did an analysis of kills by a wolf pack up at a Canadian national park in Canada, and what they found was that 80% of the animals killed had some sort of disease. It was either cancer or some sort of metabolic infection. So the point that I want you guys to understand is that when carnivores go out to hunt, they're not just randomly chasing things. They can smell which animals are sick. those are the ones they chase. Why? Because the sick ones are easier to catch, less energy expended. We are actually learning to use this ability of carnivores to detect cancer by training them to detect people with melanoma recurrences, with colon cancer recurrences, and their noses are sensitive enough that they can detect tumors well before they would show up on a CAT scan. So again, the bottom line I want you to understand, not random. They're actually actively seeking the disease, the sick, the weakened. They are strengthening the gene pool. So this is just a schematic of a carnivore skeleton showing that the heel on the wolf is a third of the way up the leg. You see the joints are permanently flexed. They are clearly in this permanent crouch, ready to run and chase something. Now we're going to look at the herbivores. I've divided them in two groups, what I call the vulnerable herbivores. Those are the ones that are often preyed upon by typical carnivores. Then we'll talk about the herbivores that are so big and powerful they are completely invulnerable to, well, not completely, but mostly invulnerable to predation. Well, again, these animals are designed for foraging. They can walk very long distances at a very low energy cost, so they have very straight limbs, not the bent joints that you see in the carnivores. And as a result, these animals are so well designed for standing, many of them can actually sleep standing up. And what this means is that as they're walking around looking for their food, they're not expending a lot of energy because it's their skeleton that's resisting gravity, not their muscles. They tend to be active throughout the day when the carnivores are asleep. They often live in large multifamily social groups. Their limbs, as I said, are straight so that they can stand with a minimal expenditure of energy. And whereas we saw that the carnivores had skinny limbs, well, in the evolutionary arms race, their limbs are even skinnier and lighter so that they can actually outrun the carnivores. That's why the healthy animals can always outrun carnivores. It's the unhealthy ones that get caught for the most part. They have what's called an unguligrade stance. Now, we remember the carnivores had a digitigrade stance, meaning they were on their toes. These animals are literally on the tips of their toes like a ballerina on point. And they also have even smaller feet, having lost multiple toes. Most of the ungulates only have 2 toes. Some, like horses, only have 1. And that, again, allows them to run even, much faster. Again, standing on the tips of the toes means longer stride length, faster speed. I've covered this. Their nails, instead of being sharp claws, are flat and blunt, helps them dig up things. And many of these herbivores have color vision, and they're usually active during the day. Their top speed, when they're healthy, is 45 to 50 miles an hour, which allows them to outrun most carnivores. Then you get to the invulnerable herbivores, which are so large and powerful, they're generally immune to predation. Their top speed, therefore, since they don't really have to run away from anybody, it's like maybe about 25 miles an hour. They too are daytime foragers. They have very heavy, straight, pillar-like limbs, because again, since they don't need to run away from anyone, they don't need these little skinny limbs to allow them to run fast. So they're these really thick, heavy limbs that allow them to stand up and not require a lot of support. They have a largely hairless skin. Nails are flat and blunt, and they have large, heavy feet, which have a flat foot-like stance. Like humans, elephants live in are long-lived social mammals living in large family groups. Terrestrial herbivorous mammals tend to live much longer than carnivores, and I think that has to do with the fact that their diets are higher in antioxidants and other things that help offset the ravages of aging. And these animals are a living testament to the adequacy of plant protein. I just want to make this point. We all know that the first thing that you get asked when you tell someone you're going plant-based, oh my God, where are you going to get your protein? The largest, strongest animals on this planet are all vegans or herbivores. All protein is made by plants. Say that with me. All protein is made by plants. No animal is able to take nitrogen out of the air and incorporate it into an amino acid. Only plants can do that. So any protein you get from an animal source is secondhand. It's secondhand plant protein. Let's cut out the middleman and go directly to the source. Okay, this is just a cartoon showing, drawing a scale showing the differences in limb structure. You can see in the carnivore, the cat, the bent limbs, in the elephant, the very straight limbs. All right, let's talk about the energy cost of locomotion. For quadrupeds, you see that when you graph walking speed versus energy utilization, you get a straight line. Faster they walk, the more energy they use. It's very different for humans. When you graph walking speed in humans versus energy expenditure over a wide range of speeds, of walking speeds, we actually use less energy than would be predicted for an animal our size. So, in other words, we are the consummate foragers. Many people have debated why humans ultimately adopted an upright stance. It's because it made us extremely efficient foragers. And why is that? Well, in a quadruped, the center of mass is always located squarely between the bases of support. So that means every time that animal has to take a step, it has to lift up its center of mass, move it forward. That requires energy. It's not that way for us. When we take a step and our leg gets thrown out, your center of mass actually falls outside of your body. You start to fall forward. In other words, gravity is now moving you forward. Gravity is doing part of the work of helping you move. And if you don't catch yourself in a nicely timed fashion, you're going to fall on your face. That's why stubbing your toe makes you look so ridiculous. It's because our walking is this finely tuned ballet of appropriately catching ourselves before we fall on our face. And anything that interrupts that will make us look very goofy. So, again, human beings, consummate foragers. We're more efficient walkers than anybody else. Let's just look at human body plans. Now, you remember in the carnivores, they had this streamlined torpedo shape. They could run very fast and very efficiently. All of their vulnerable parts of their body were located in the rear of the animal, so it was protected from injury. Look at us. Number one, we have the widest part of our body presented to the wind so that it's non-aerodynamic. We have the most vulnerable parts of our anatomy right up there to get injured. We clearly are not designed to chase things down and kill it. We have this unprotected exposed anatomy where our bodies are flattened, non-aerodynamic. We have a very lithe, flexible neck that, as I found out in my car accident, can be easily injured. We have very straight, heavy, pillar-like legs, not the skinny legs of an animal that's designed to run fast. We have large, heavy, flexible feet, which helps us stand up. But that means that when we try to run, we got to lift these big old heavy things up and try to run, and that requires a lot of energy, and that's why we're lousy runners. We have largely hairless skin, our nails are flat and blunt, and lifestyle factors make humans relatively invulnerable to predation. That is, we live in social groups, we're active during the daytime, and we take our butts to bed at night when the predators are active. And that's why, unlike a lot of animals, you notice how if you shine a light into your dog or cat's eyes, it shines, it reflects. That's because carnivores have a layer, a reflective layer, a mirror-like layer at the back of their eyes that helps to amplify low light levels. It's called the tapetum. That helps them see well at night so they can sneak up on sleeping animals. We don't have that. If there was ever a human ancestor that had it, he or she got eaten and didn't pass it on to the rest of us. Our slow speed and poor endurance, most useful for escaping stinging insects. What do I mean by that? Well, the fastest humans run, even Olympic sprinters, run somewhere between 19 to 22 miles an hour. And humans can only keep that speed up for about 150 meters. Even in the 200-meter dash, you will notice that after 150 meters, all of the runners are starting to slow down because they can't keep up that speed. That is clearly not fast enough, nor is that the endurance that would allow you to chase down anything. But what it does allow you to do is escape bees and wasps, because it turns out that most bees and wasps will only chase an animal for about a 200-meter radius around their hive, and their top speed is about 19 to 20 miles an hour. So basically, our ability to run helps us escape insects when we steal their honey and try to get away from them. All right, and then when you look at women, it becomes even more ridiculous to talk about human beings as hunters, because it's crystal clear that a gravid woman is in no condition to hunt. Well, yeah, that's true. And so the anthropologist said, well, you know, what the women did was they waited at the door of the cave while the men went out to hunt. You know, Mother Nature is no fool. She knows that we guys are completely undependable, and she would not stake the existence of human females on men. The female of every species is always able to procure the diet she needs to live, carry a pregnancy, and raise her young. Every single species. There is no species on Earth where the female of that species is unable to procure the diet she needs to live, carry a pregnancy, or feed her young. That is just ridiculous to postulate that. And what is even more interesting is that the long gestation period of humans is typical of large herbivores. Human fetal development also suggests that being herbivores is a necessary prerequisite for human brain development. I had to take that part out of this lecture because it's just not enough time. But as with all other large herbivores, single births are the rule, and we have very large infants relative to the mother's body weight, and when the babies are born, their eyes are open, which is a gauge of brain development. So here's a chart showing you carnivores, at the top, and length of gestation, and some large-body herbivores. Now, I use terrestrial mammals that were about 40 kilograms or greater than 40 kilograms of body weight, because obviously it'd be ridiculous to look at rabbits or mice, but it would be equally ridiculous to look at elephants and rhinos. So try to get animals that were roughly in the same body mass as us. And what you see is, again, the human gestation period of 40 weeks is typical for large-bodied herbivores. The carnivores all have their babies at a very early stage, and that's because a massively gravid female cannot hunt effectively. She would risk injuring herself and or her developing fetus. These contrasts become even more stark when you look at the neonate's body weight as a percentage of the mother's body weight. Again, carnivores have tiny little babies, and they typically have litters, whereas in the herbivores, they have large babies that are a much bigger percentage of the mother's body weight, and they tend to have either one or two babies. Carnivore infants are born with their eyes closed because effectively they complete their development outside the womb. And just a word on milk composition. When you look at the milks of carnivores, this is divided by total solids, percent fat, percent protein, and lactose. You see that the carnivores have a lot more solids, a higher percentage of fat, and a much higher percentage of protein. Why? Because their babies grow very, very rapidly. You only need high protein milk if your baby's growing rapidly. Down at the bottom, I put cows and humans to show you why you should not feed your baby cow's milk. And what you see, again, typically carnivore milk contains more than 1.5 to 2 times more solids than herbivore milk. They have 2 to 4 times the protein and up to 10 times the amount of fat. What I want to show you about cow's milk is that cow's milk contains almost 3 times as much protein as human milk. Why? Because calves grow much faster than human babies. Bovine proteins are qualitatively very different from human proteins, and also the fat that's in cow's milk. Cow's milk has more fat than human milk. Actually, the fat is roughly the same. The protein is different. But the lactulose is very interesting. You notice that humans have more lactose than cow's milk. Lactose is milk sugar. Why should that be? That's because a human infant's brain, relative to its body size, is much bigger than a calf's brain. And the brain uses only glucose for its metabolism. So our babies need more sugar, but they don't need all that protein. And even though the percentage of fat is roughly equivalent, it's very different kinds of fat. The fat in cow's milk is highly saturated, which is why you can make butter and ice cream from it, but you cannot milk a woman and make butter and ice cream from her milk. All right, let's move on to the head neck region. As you can see, carnivores have a very wide mouth gape, so they can run up, grab something, and start to rip it apart. The temporalis muscle, which is a muscle that sits on the top of the head, is the primary muscle operating the jaw. Teeth are designed for ripping and tearing. They don't chew their food. Their jaw has minimal side-to-side motion. Their saliva has no enzymes. So again, key, they don't chew. They rip off a hunk of flesh, swallow it whole. If the animal is small enough, they'll simply swallow the entire animal. When you look at bite forces, here's a picture of the jaw. You can see that the jaw joint in carnivores is on the same plane as the teeth. They have these giant canine teeth, and the molars are blade shaped, and you see that the upper molars slide completely past the molars in the lower jaw to give you a nice slicing motion. So their jaws act like a pair of shears when they close. The teeth slide past each other in a nice cutting motion. This area called the angle of the mandible, which is where muscles called masseter and pterygoids attach, is very reduced in these animals because they don't play any part or a minimal part in the operation of carnivore jaws. Again, they have very strong bite forces. Estimations, dogs can do 300 to 450 pounds per square inch. Wolves are greater than 500. A jaguar can do 700. Lions and tigers, 800 to 900. Hyenas greater than 1,000. And by contrast, we have a puny 150 pounds per square inch. So it's good enough to crack a nut, but not a bone. Now, when you look at the herbivores, very different. Instead of that reduced facial musculature, very well-developed facial muscles. Very small opening into the oral cavity, and this area called the angle of the mandible is nice and expanded because the muscles that attach here, on the outside, it's called the masseter. On the inside, it's called the pterygoids. Those are the primary muscles operating the jaw in herbivores. This area at the top is very small. That's where the temporalis attaches, does very little in herbivores. This is a sheep showing the same thing. The other important thing, instead of the jaw joint being on the same plane as the cheek teeth, it has moved to a position above the plane of the cheek teeth so that the lower jaw has an L shape. And that allows that lower jaw to be much more mobile so that they can develop the grinding motions of chewing. This type of jaw structure is believed to have evolved more than 15 times. The lower jaw has pronounced side-to-side motion, can move backwards and forwards to give you those grinding actions of chewing. And in some herbivores, the saliva has an enzyme called salivary amylase, which digests carbohydrate. When you look at the cheek teeth, again, you have these teeth that are like little steak knives, whereas in the herbivores, they are flattened and made for grinding. When you actually look at jaw motion, what you see is that when a carnivore closes its jaw, the teeth slide past each other in a vertical motion. In the herbivores, the teeth slide across each other in a horizontal motion. I'll let you figure out what your jaw does. Because herbivores have well-developed facial muscles, they can do something carnivores can't do. They can create a vacuum. That's why they can suck up water, and carnivores have to lap it up. The esophagus, which is the tube that leads from the throat to the stomach, in carnivores is big, wide, and stretchy, and it allows them to swallow big hunks of meat and bones, and they don't have a problem. In the plant eaters, it's much more narrow and muscular, and that is why when humans eat meat, we often end up choking to death. 90% of the people who choke to death every year choke to death eating meat, and the number one culprit is hot dogs. That's in the ear, nose, and throat literature. All right, upper GI tract. Just to make kind of an obvious point, in animal tissues, there's no fiber. There's only the cell membrane made up of fatty acids. And then there's protein, water, and fat on the inside. So animal tissues are actually very quickly and easily broken down. So animals that eat other animals don't need long, complicated digestive tracts. Now, this is critically important. Their stomachs are huge. The thing you have to understand about hunting is inefficient. In the wild, carnivores typically make a kill once every 7 to 10 days. Now, they try to hunt every day, but they're usually only successful once every 7 to 10 days. That means that when they finally do make a kill, they have to be able to ingest enough calories at that one meal to make up for all of the energy wasted chasing things they didn't catch, and also to last them until they can make another kill. And so their stomach alone holds 60 to 70% of the total gut capacity, and it allows them to consume roughly 30% of their body weight at a single meal. That means that a 300-pound lioness can consume 90 to 100 pounds of meat at one meal. And that means that if you had a stomach like a carnivore and you weigh, let's just say 150 pounds, that means that you would be able to eat 45 pounds of food at a single meal. Who can do that? And this is because their stomachs are designed for intermittent feeding. Feeding today, not eating again for a week or more. And this is also why our pets tend to get overweight, because we feed them every day. And in the wild, they would not be eating as often. I'm not saying don't feed your pet every day, because they will look at you with this look like, I have never eaten in my life. Why are you doing this to me? But you need to feed them smaller portions. And then this comes up to the concept of recoverable energy. The huge capacity is necessary because hunting is inefficient. It means that they have to, as I said before, be able to extract enough energy to make up for what they didn't catch and last until they can make another kill. This means that a 50-kilogram wolf can eat up to 21,000 calories at a single meal. If you tried to do that, it would kill you. Again, enough energy to recover what they wasted and last them until they can make another kill. And because they can eat rotting tissue, that means if they can guard that carcass and keep other animals from stealing it, they can extract additional energy from it. Their small intestine, which is where the actual absorption is done, is very short. It's only 3 to 4 times their body length. It's mainly lined with protein and fat digesting enzymes. And they can actually go for long periods without eating and still not have a problem eating a large meal and ingesting it. We can't. There were some tragic instances at the end of World War II when the death camps were liberated. They saw these starving people. The GI started giving them all kind of food. They ate it, and many of them went into shock and died. And that's because their digestive tract was no longer mature. They were not able to keep fluid in their bloodstream. It all went into their GI tract. They developed massive diarrhea, circulatory collapse, and died. Carnivores don't have that problem. Bears can not eat for 6 months, get up, find a dead carcass, gorge themselves, and they're just fine. And this is just a picture showing the typical appearance: large stomach, short small intestine, short large intestine. All right, now to make an obvious point, plants don't have bones. Therefore, they use fiber to stiffen their tissues and resist the force of gravity. And so what that means is all plant cells, in addition to having a cell membrane, has a cell wall that is made up of cellulose. But because of the presence of cellulose, that means that animals that eat plant tissues require much longer, more elaborate digestive tract. Now, I'm just going to briefly mention there's 2 different strategies for dealing with the cellulose. There's what are called the foregut fermenters, which are the ruminants. These are the animals that eat mainly roughage like grass and hay and so forth that has very little intrinsic nutrient value. So they ferment their fiber up front. They have a stomach that contains this soup of bacteria that releases enzymes that can digest cellulose, because humans do not make enzymes that digest cellulose, but bacteria do. So what do? They go along, eat a stomach full of grass, swallow it, let it go into this first stomach, soak up those enzymes released by the bacteria. Then what do? Come on, you guys know this. They bring it back up and chew the cud, because the purpose of chewing is to mix food with digestive enzymes. And in the foregut fermenters, the enzymes are in the stomach. They soak it up, bring it up, chew it. In the animals who are hindgut fermenters, they have enzymes in their saliva, and that's why they chew their food. Carnivores don't have enzymes in their saliva. They do not chew. So how do you know if you're looking at a foregut versus a hindgut fermenter? Look at the poop. And a foregut fermenter is liquid. which is why a cow patty is liquid when it's fresh. And then the hindgut fermenters, like horses, you see they pass a very fibrous stool. But that's the last we're going to say about the multiple stomach herbivores. The herbivores with the simple stomach holds about 30% of the total gut capacity. When food is in the stomach, the pH of that stomach is only about 4 to 5, which is only moderately acidic. I forgot to mention to you guys that when carnivores' stomachs are full, they can secrete so much acid that the pH of their stomach is less than 1. That's strong enough to dissolve not only bones, but it'll dissolve a penny. But because these herbivores have smaller stomachs, they have to eat multiple times a day because their small stomach cannot contain enough food to last them even one day. So they must eat multiple times a day. They are batch feeders. The carnivores are intermittent feeders. The herbivores are batch feeders. Small intestines, very, very long, over 10 to 12 times body length, and that's because fiber slows down the absorption of nutrients and they need a large surface area. They have an unlimited capacity for carbohydrate digestion and absorption. Just to look at some herbivore digestive tracts. And again, in a rabbit and equids like horses, small stomach, long, small intestine. And you notice that the large intestine has this pouched appearance. It's very different for a ruminant like a dik-dik, but we're not ruminants, so we don't care. All right, let's look at the lower GI tract. In the carnivore, the colon is very short, very straight, smooth, and that's because by the time any residue gets to the colon, the only thing that will happen is it will rot and release toxins, so the animals want to get that stuff out of their bodies as quickly as possible. The herbivores, by contrast, have a much longer large intestine, and that's because there's a lot of fiber left over after they've extracted the nutrients from the plant foods, and the bacteria in the colon can then work on that fiber, break it down, and they can absorb things like they produce vitamins, they can absorb short-chain fatty acids, and do a lot of wonderful things. All right, what about us? Well, when you look at human teeth, you see we have, instead of short peg-like teeth and long canines, we have these blunt, flat, spade-like incisors that are wonderful for peeling fruit, but lousy for trying to bite into an animal carcass. And even though we have canine teeth, they are small, reduced in size and shape, and act like accessory incisors as opposed to actual canines for killing something. You can see that our jaw joint has moved to a position above the plane of the teeth. We have the typical L-shaped jaw of the herbivore. I want you, everybody, to put your hand right here and bite down. You feel that muscle that's popping out? That's your masseter. The pterygoids are on the inside. They hold the lower jaw in a sling-like arrangement, move it side to side to help you grind up your food. This is just a comparison of jaws. It's very easy to see who we're like. We are nothing like the carnivore here. We have the typical jaw structure of an herbivore, and you notice that even horses have small canines. So the idea that just because you have canines, you're supposed to eat meat is ludicrous. And again, in both the herbivores, the temporalis is very reduced, whereas in the carnivores, it's a gigantic muscle. We have a very walled-in oral cavity, which allows us to chew our food very well, develop a vacuum, suck up water, use a straw, and we have these nice fleshy lips, which I know you all thought the purpose was for kissing, but it's actually to help you move food into your mouth. Kissing is just a fringe benefit. Again, this is a view of the oral cavity from the inside. You can see the pterygoids on the inside, masseter on the outside. And we have a large salivary gland right behind the ear, or in front of the ear, called the parotid gland, that manufactures an enzyme called salivary amylase. And when you chew your food thoroughly, most of the carbohydrate digestion is actually due to the enzyme in your saliva, not the enzymes in your that come from your pancreas. The tongue is thick and muscular, helps us in chewing our food, also aids in speech. The structure of our pharynx actually allows us to have a much broader sense of taste than probably any other animal, because food molecules pass through the back of the throat into the nasal cavity, giving us a much broader sense of flavor, which is why it sucks when you have a head cold. As I said before, our esophagus is very narrow, muscular. It's designed to handle very small balls of thoroughly chewed food. And people who eat a lot of meat tend to get what's called gastroesophageal reflux disease, which, if untreated, can lead to esophageal cancer. Human stomach holds about 20 to 25% of your GI capacity, only moderately acidic with food, and is designed, again, for batch feeding. Unless you are eating pure olive oil, you cannot consume enough calories at one meal to last you even a single day, let alone 10 days. So that is why, like all herbivores, we have to eat multiple meals throughout the day. And because the small capacity of our stomach and our inability to eat carrion, hunting is much less efficient for us. Because if you go around chasing something, trying to kill it, and finally succeed after 10 days in killing something, you can't even consume enough calories at that one meal to replace what you've just expended trying to hunt. Furthermore, once that carcass starts to rot, you're done. So hunting for us, the metrics don't add up. Now, some people have said, and I had a whole section in here about this, oh, well, we ran animals to exhaustion, which is, let me just say, one of the stupidest theories that has ever been invented by human beings. There is no carnivore in existence that ever tried to run an animal to exhaustion. Why? Because you're going to expend this ridiculous amount of energy trying to catch this animal that you're never going to recover once you actually catch it. You're going to end up starving to death. And if you starve to death, you don't make copies of yourself. You don't make copies of yourself, we don't see you. All right. So this is why in the absence of large-scale preservation methods, hunting was simply not an efficient way of obtaining food for Stone Age humans. Now this is different in temperate areas where it gets very cold, it gets freezing, you can kill something and preserve it. But in equatorial regions where humans are believed to develop, just is not a good way of trying to obtain food. And that's why plant-eating locusts were considered a plague and not a food bonanza. All right, when you look at our small intestine, human small intestine is typically 25 to 30 feet long. Now remember I said that the small intestine in herbivores was 10 to 12 times the body length, right? So if I'm telling you that a 6-foot man has a small intestine that's, say, 30 to 35 feet long, is that 10 to 12 times his body length? Yes, it is. Your body length is not measured head to toe, it's measured tail to tailbone. Your torso length is 2.5 to 3 feet. You have the classic dimensions of a plant eater. And then your small intestine is further lengthened by being kind of compressed like an accordion. And then when you actually look at the lining, it's thrown up in all these little finger-like projections called villi. And when you look on the surface of those, they have these little things called microvilli. It means the total surface area in your small intestine is roughly the size of a singles tennis court. So the next time you go to play tennis, think, oh my God, all of this is right inside of me. And the human colon, extremely long for a creature our size. It has a typical pouch structure that we see in herbivores. It also has an appendix. And far from being a vestigial organ, we now understand that the appendix is part of the GI tract immune system. And furthermore, only herbivorous mammals have an appendix. Carnivores do not. And in our colon, we do a lot of things. We break down fiber or ferment it. It produces short-chain fatty acids that gives us additional energy and does a lot of wonderful things for our physiology, produces vitamins, and finally we eliminate what's left over. Food actually spends more time in your colon than it does anywhere else in your digestive tract. Now, this brings up the concept of food retention time, the amount of time a meal stays in your body. And you might say, well, you know, Dr. Mills, everything that comes out looks the same. How do I know how long it's been in there? Well, the next time you eat whole kernel corn, look at your watch when you eat it, and then mark the time when you see it again. And that is the food retention time. It's typically, now if you are like a real hardcore super vegan, it can actually be as low as 12 hours. But it's typically more like 16 to 18 hours. So we'll say 18 hours. Food stays in your stomach a maximum of 3 hours. Your meal passes through the entire length of your small intestine in 2 hours or less. That's 5 hours. That's 5 from 18 leaves 13. Where is it spending the majority of its time? In your colon. And it's not supposed to be sitting there like some big lump of nonsense. It's supposed to be acted on by a bacterial population that will break it down into these short-chain fatty acids that do wonderful things for your health. One of the short-chain fatty acids is called butyrate. It's 4 carbons long. It turns out that butyrate is the preferred fuel for colonic cells. They don't like to get their energy from your bloodstream. They prefer to get it from the intestinal lumen, the butyrate. When you have a lot of butyrate, you have a very healthy colon. Then they make a 3-carbon short-chain fatty acid called propionate that is absorbed, goes to the liver, and inhibits an enzyme called HMA-CoA reductase. All right, for the doctors out there, why is that important? Cholesterol, that is the same enzyme that statin drugs inhibit. So this drug will do what medications do without the side effects. Propionate also helps reduce your liver's production of glucose, like another drug called, oh, come on. What? I mean, Frankenstein's not on this stage. Speak up. Glucophage, right, metformin, another popular diabetes drug. And then a 2-carbon short-chain fatty acid called acetate is used by your body cells in lieu of glucose, which means that your glucose stores last longer, your brain is happy, you don't get hungry as often. And then you get what's called activation of these phytoestrogens and lignans in the plant foods that we eat that makes them much more bioavailable and bioactive. Breast cancer risk decreased by 22% in women who consume the most lignans. Whole grain rye decreased PSA levels, or prostate-specific antigen levels, by 14% in men with prostate cancer. Consumption of soy phytoestrogen reduces breast and prostate cancer risk in a dose-dependent fashion. The more you eat, the healthier it is. Why should phytoestrogens reduce prostate cancer risk? We don't have estrogen in our body. Well, it's because when your liver sees those phytoestrogens, it thinks that it's seeing steroid hormones, and it starts ramping up its production of something called sex hormone binding globulin, which then goes into your bloodstream, latches onto estrogen if you're a woman, or latches onto testosterone if you're a man. And we know that the lower your levels of unbound estrogen or testosterone, the lower your risk of breast cancer or prostate cancer, respectively. So that's why these things are so healthy. And the metabolism of these phytoestrogens, as I said, makes it more bioavailable. But the other point that I want to make is that the strains that are most effective at doing this are those that are associated with a plant-based diet. You eat too much meat, you get the rotty kind of plant food of bacteria that can rot and make very stinky methane, but they don't do a whole lot for your phytoestrogens. And then this just shows that when you have a diet that's very high in fiber, gives you a much thicker layer of mucus, which prevents bacteria from getting into your bloodstream. It makes a lot of this butyrate, which keeps these bacterial cells very happy, and they bind very tightly to each other. And it also upregulates the strain of bacteria that's very healthy for you. They also do other amazing things that I simply don't have time to go into, like when you eat cruciferous vegetables, there's a receptor on your colonic cells that actually stimulates immune cells to be much more active. But again, we just don't have time to talk about all that. And as you can see, with fiber, you have this butyrate, very thick layer of mucus, very tight binding, and you have a very healthy colon and no translocation of bacteria into your bloodstream. But when you don't have a lot of fiber in your diet, this is what happens. A very reduced layer of mucus. You see these cells are not binding to each other very well, and then these bacteria start slipping down between them, get into your bloodstream, and ramp up the level of inflammation in your body. And this is called leaky gut. Why is that important? Because leaky gut has been linked to a number of problems. The inflammation can cause depression. If you look at controls, those with low level, this is lipoprotein, lipopolysaccharide, antibodies to a bacterial antigen, In the people without depression, they have very low levels, and people who suffer from major depression, much higher levels because they're not eating the right foods. And again, bacterial endotoxins that increase inflammation enter the body through this leaky gut mechanism that we just talked about. The other important thing to know is that they can be absorbed in both raw and cooked meat. Cooking meat does not destroy these endotoxins. So if it's there, it's going to be absorbed. All right. Studies show that a single meal that's high in animal fat can induce the absorption of these endotoxins, ramp up the amount of inflammation in your body. This is just a slide showing median trophic levels of various countries. In other words, this is a measure of per capita meat consumption worldwide: United States, Argentina, Europe, so on, Australia. Why is that important? Because when you look at meat consumption graphed versus the incidence of Alzheimer's, what you see is that in those countries with increasing consumption of meat, they have the highest levels of Alzheimer's. As people become more plant-based, they have lower levels of Alzheimer's. Again, I'm rushing because I'm trying to get through all this, folks. And this is just showing inflammation and dementia. Again, the higher the level of inflammation, the greater the problems with dementia. If you guys kind of tap into the film, you'll be able to read all the information on these slides when you review later on. So our digestive system is designed to quickly absorb and extract all of the readily available nutrients in the small intestine, pass the fiber on to the colon, where it's fermented into a lot of wonderful compounds that improve our physiology. Bottom line, fiber fermentation is essential for normal physiology, optimal health, and brain function and brain protection. Your colon is not just a big storage organ for stool. It is a major organ of digestion. It is where your meal will spend the most of its time, and you need to provide it with the substrates, the bacterial population they need to do the job that they're meant to do for us. All right, quick note on physiology. Do carnivores worry about fat and cholesterol? Of course they don't. Dogs and other carnivores will not develop heart disease no matter how much fat and cholesterol you feed them. They don't develop gallstones because their bile is so strong it will dissolve gallstones. That is unfortunately why bear bile is prized in Chinese medicine, because if you drink bear bile, it will actually be concentrated by your liver in your own gallbladder. And if you have gallstones, that bear bile is so strong it will dissolve those gallstones. Now, we have medicines that do the same thing now, so you don't need to kill bears. And if you eat the right foods, you won't get the gallstones in the first place. Carnivores can detoxify preformed vitamin A. They manufacture their own vitamin C. They can concentrate their urine up to 2.5 times more than we can, which means that they don't get all dehydrated when they eat high-protein diets. And they can also metabolize this excess animal protein without damaging their bones. That may seem like they've got us beat out of the block, but we can do some nice things that they can't do. We have enzymes in our saliva that digest carbohydrates. We can absorb, we have essentially an unlimited capacity for carbohydrate absorption. As I said, we have, herbivores have an appendix. Although we cannot detoxify preformed vitamin A, we can take beta carotene and convert it into vitamin A. Carnivores can't do that. So you see, if you eat enough colorful vegetables, you'll never be vitamin A deficient, because your body will convert as much beta carotene as it needs into vitamin A to keep you replete. The excess is stored in your skin. Why? Because it acts like a natural sunscreen. That is why these plants make these pigments. That's why they have these colors. It protects them from sun damage. And when you eat the plants, you get the same type of protection. These pigments are stored in your skin where they help protect your skin from sun damage. We can detoxify a wide range of plant alkaloids, which is why we can take aspirin and stuff like that and not get sick. But we require a dietary source of vitamin C, but if you're eating plant foods, you're cool. We cannot eat rotting flesh, and we easily develop heart disease if we eat a diet high in fat and cholesterol. Just a quick point that I want to make about calcium, because people, if I don't eat dairy foods, where am I going to get my calcium? First of all, cows don't drink milk. They have plenty of calcium in their milk. And why is that? That's because calcium is found in all green leafy plant foods. Now, the reason I got this moose up here is because we've all seen a picture of an adult moose, right? That rack of antler weighs about 85 pounds and is made out of solid bone. And the moose grows those antlers in a span of about 3 months, eating nothing but green leafy plant foods. Who's 6 foot tall in here? All right, this gentleman. If I took you, flayed all the skin off your bones and your body and boiled you down till I had nothing but your bones, your entire skeleton only weighs about 35 pounds. Took you probably 25 years to grow that. A moose can grow 85 pounds of bone in 3 months eating plant foods. You do not need dairy foods. All right, just again, quick word about epigenetics, because people have been talking about this concept of epigenetics. Literally means above the genome. And what we have come to discover is that eating plant foods actually modifies the proteins that surround our DNA in ways that help regulate the function of our genes. It turns off cancer-causing genes, turns on protective genes. And the other important, so in other words, your diet helps control your DNA. And the reason this is important is because you pass these effects on to your children and grandchildren. As I said, all DNA is coded by these histone proteins. We know that diet can change the gene transcription rates, and you can think of the epigenetic effects as software versus hardware. Your DNA is your hardware. The epigenetic changes are the software. As I said, these influences are heritable. In humans, they've been shown to persist out to about 3 generations. In lab animals, such as rodents and flatworms, they can persist out to up to 40 generations. Epigenetics of cancer is well studied. If you lose these methyl attachments, you become, these oncogenes become more active. A study published in the British Journal of Medicine, Thaler showed that epigenetic regulation changed the function of something called superoxide dismutase in our mitochondria. And of course, Dean Ornish showed increased telomerase activity after only 3 months on a plant-based diet. So, just some closing thoughts. My feeling is that in a lot of cases, we have abdicated responsibility for our health and that of our children by allowing profit-driven marketing campaigns to dictate how we eat and feed our families. We gorge ourselves on unhealthy foods, stuff our kids full of these misnamed Happy Meals until they start to look like little pint-sized Michelin men, and then we throw our hands up in despair when they develop asthma, obesity, diabetes, heart disease, cancer, depression, and so on. It's important to realize that the chronic diseases that afflict us did not fall from the sky at the behest of some malevolent God. They are the consequences of our own actions. As such, it is within our power to change our behavior and improve our health. And this is critically important. We were all born without preferences. Nobody asked for fried chicken, ice cream, or pork chop in the delivery room. Everything you think you like, you had to learn to like. And just like you learn to like things that are unhealthy, you can learn to like things that are better for you and don't destroy the planet and don't harm your children. How many people here are married to the first person they fell in love with? Okay, a few, but most of us aren't. And think about that first person you fell in love with. There was a time you thought you couldn't live without that person. And then they did something or said something stupid and you're like, what am I doing? In my case, she used to leave her shoes in the middle of the floor. But the point is, just like you learn to love someone else, you can learn to love something else when it comes to your diet. And once you love something, you love it. And we have to do this not only for our own benefit, but for the health and well-being of our children and for the benefit of the planet and its other inhabitants. Now, last thought. In the Bible, the story is told of Naaman, who was a Syrian captain, a captain of the Syrian army. He had leprosy. And he heard about the prophet Elijah, so he gathered up all these gifts in this big retinue, and he went to Elijah's house, and he basically sent his servant in to say, please come out and cure me. Elijah didn't even bother to step outside. He simply sent the servant back out and told Naaman, go bathe in the river Jordan 7 times, and you'll be cured. When Naaman heard that, he was furious. He's like, I came all this way, and you won't even come out here and talk to me? And then you're going to tell me to go bathe in that muddy river when we got better rivers in Syria? And he was about to storm off, and his servant came near to him and said, my father, if the prophet had bid thee do some great thing, wouldn't you have done it? Well, how much better that he just said wash and be clean? And when it comes to our health, we are willing to let people crack open our chest, strip veins from our legs, shoot us with radiation, fill us with toxic chemicals in an effort to get our health back, carve out pieces of our internal organ. Isn't it much better to do the simple thing and eat the plant-based foods we're meant to eat in the first place?
Well, thank you very much, Dr. Mills. That's the best presentation I've seen on something that's talked about so often, and that's the difference in our anatomy and physiology.
Yeah,
Nobody's ever done it better.
And I just want you guys to understand that if you saw me working on my computer all day yesterday, I was taking stuff out.
Yeah, really.
There is way more stuff that we could talk about. The differences are not subtle. You are absolutely designed to eat plant foods, which is why when you switch to a plant-based diet, your health improves, your disease risk goes down, and the earth is better off.
Well, everything you say is consistent, and the truth has to be consistent. And you did a beautiful job of putting every
Thank
part
you.
of the anatomy and physiology together. I think we probably have time for a couple of questions.
Phenomenal analysis. Thank you so
Thank
much,
you.
Dr. Mills. Very interesting. I saw from your slides that you seem to be supporting the consumption of soy. And there's been quite a controversy about soy. And I'm not just talking about GMO versus non-GMO.
Sure.
Should we be eating fermented soy? Is that better than regular soy? What about raw soy? Do you think soy is in general an important part of
Sure.
a vegan's diet?
Okay. Yes, I do. I mean, I know there's a lot of stuff on the internet that suggests that there may be problems with soy, but just a couple simple things. Number one, if soy was really deadly, then Japan and China would be the sickest places on earth, and they're not, because they have a diet that's heavily based on soy. I think soy is a part of a healthy plant-based diet. The studies that I'm aware of show that it actually helps protect us and improve our health. You shouldn't eat nothing but soy, but to have soy as a part of the diet, I do think is healthy. And if I'm mistaken and there's a doctor in here that can refute that, please speak up right now, because I don't want to hand out misinformation. But all of the studies that I'm aware of show a protective effect for soy foods in both men and women. All right.
Dr. Mills, there is soy, and then there is soy. There are soy hot dogs. They're
Well,
different.
right. I mean,
You're
the more
talking about-
natural
you're
forms.
talking about
Tofu,
natural soy.
tempeh,
Yeah.
not the highly processed.
I just want to get that clear.
Yeah, no,
because there's
that's
some
an
people
important
run
point.
just thinking they
That's
way
a
home
very
get
important
Boca
point.
burgers and fake chicken.
Yeah. I mean, an occasional soy delicious. Go ahead.
I've had a couple of people say to me, I need protein. What? Like, I need protein for my breakfast because I'm going to be on an airplane all day. What do you think they want? Have they been brainwashed?
They're
Is there
psychologically
something they're
addicted.
desiring? I don't get it, but sometimes I think it's a reaction to me.
Sure.
You know?
It's people will make excuses not to change. Again, the point that I made is that all protein is made by plant foods. All plant foods have protein in them. Some are protein dilute, like fruit and some of the water-containing vegetables, but they're concentrated sources of protein, such as beans, nuts, legumes, and even your root vegetables have a fair amount. So if you're eating a healthy plant-based diet, look at the elephant. It didn't get that way by sucking on cotton candy. I mean, there's plenty of protein in plant foods. That is just something people say because they don't want to change. I can tell you from my own experience, there was a time I thought I could not live without meat. And once I made the change, I realized it was an addiction. You know, people, when we talk about addiction, we want to talk about alcoholics, meth addicts, crack addicts, and heroin addicts. You have not seen the face of addiction until you try to take a piece of fried chicken from somebody. That is why people don't want to change. All right, go ahead.
I saw you like 10 years ago at VegFest, and other than Dr. McDougall, you remain the most convincing speaker on why we are herbivores.
Wow, thank you.
But my question is, when I state that emphatically to friends or family, they'll go, no, 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 we're omnivores. And I noticed you didn't really have a section refuting omnivorism.
Yeah, I do, but because I only had an hour, I couldn't put it in. This lecture is typically a 2-hour lecture. It's done in two 1-hour sections. But we had a limited amount of time, so I had to decide what I could take out. But there are, by design, omnivores in nature, such as bears and raccoons and so forth. And they're essentially carnivores that have slight modifications to their digestive tract that allow them to eat some soft, pulpy plant foods. But they are still retain the carnivore body structure, the giant stomachs, the ability to eat rotting tissue without problems, and they can't eat diets that are super high in roughage because they can't extract the nutrients like we can. So yeah, no, it's the information is there, just couldn't put it in. Oh yeah, it is in the handout. Yeah, you all got your handouts, by the way, right? And I mean, that's an abridged version of this talk, but I at least wanted to have you guys go home with something.
One of the last resorts that omnivores seem to go after is that chimpanzees eat flesh.
Yes.
Do you address that?
Thank you for asking that question. People say, you know, we share 99% of our DNA with a chimpanzee, and they eat termites. Well, do you realize that you have 58% DNA homology with a tree? But I don't think any of us can produce an apple from our fingertips or suck up water through our feet. So that DNA homology analogy is overworked. Look at a chimp's diet. Chimps are frugivorous, meaning they eat primarily fruit. Fruit is very low in protein. So yes, they need to supplement their diet periodically with a few termites. Human beings are marked by being able to go out on the savannah, and we eat from a wide range of very high protein energy sources. So we don't need the animal foods to supplement our intake, because there's a very good paper by this researcher by the name of Jolly, where he talks about early humans as seed eaters, that we learned to exploit grass seeds and legumes to get the protein that we needed, so that we did not need to waste our time trying to run around and chase animals.
Thank you. It's rebuttal time.
Well, just by coincidence, we have a herbivorous meal plan, lunch.
Okay, all right.
Just by coincidence.
All right.
Thank you very much, Dr. Mills.
All right, thank you.